Hello everyone, this video is gonna cover the lecture notes for week 13. We're almost there. Remember there is only 16 weeks. Now, this week is technically a continuation of week 12. You remember in week 12, we talk about vertical and horizontal asymptotes. And horizontal asymptotes, there were technically 3 cases, which we're going to repeat right now, where n was equal to m, n is less than m, and then there is one when n is bigger than m. In week 12, we covered this case and this case, but we haven't done this one yet. So this is what we're going to do in week 13, and we're going to review also these 2 cases, but this is the main point of week 13. All right, so first I'm going to refresh your memory on these 2 cases. Remember, you have a rational function that looks like this. Remember, the degree of this one is n, the degree of this one is m. So if n and m are the same, then that means that Rx is equals to an x to the n plus a1 all the way to the y-intercept. And then in the bottom, this will be bn x n, since now they have the same degree. This will be b1, and then finally b0. So remember, if these 2, and you have this in the last quiz actually, if these 2 are the same, then the horizontal asymptote, you just divide the coefficients, which will be an over bn. Also, last time we went over this. If the degree from the top is less than the bottom, then the horizontal asymptote is always equals to 0. That's probably the easiest case. So now we're gonna look into what happens if the degree of the numerator is bigger than the denominator. And depending on the case, this is usually what we call a slant asymptote. Okay, so we'll get to that in a little bit. So now, then first example, notice how the degree of the numerator is 2. So in this case, the value for n is 2, and the degree for the numerator is 1. So clearly, n is greater than m. So here to proceed, because if you take the limit as n goes to infinity, since this goes to infinity, this automatically goes to infinity. So that's not going to help you much. So therefore, what you do is you have to do long division, and people really hate long division, but unfortunately you have to do it. So this is how you do it in case you forgot. So we're dividing x squared minus 4x over x minus 3. And first, you need a number here that when you multiply times this one will give you x squared. Obviously, the only choice is x. There's always only one choice. So this will be x squared minus 3x. And then you change the sign. So this becomes minus, this becomes plus. And then you add this. You should always get 0 for this one. And in this case, this is minus x. Then just repeat. Well, the only one that is going to give you minus x, since you already have x, is to have a minus 1. So this will give you minus x. This is minus 3. Then change the sign. Remember that the first one always has to be 0, and then this is a. And this is the remainder. All right, so that implies that you can actually rewrite the rational function as this: x minus 1, then minus, this should be minus 8. So this is plus, and this should be minus. So this is minus a over x minus 3. So this is exactly the same thing as this. This part is what is going to be called the slant or oblique asymptote, and this is obviously the remainder. Okay. Notice that as x goes to infinity, this will go to 0, so the only thing that will remain is this, and that's why this is called the slant or oblique asymptote. So in general, if you have a rational expression r of x, which is always has to be a polynomial divided by another polynomial, and once you do the long division, you end up with this. This will give you ax plus b, and then plus the remainder. Okay, so this will be the remainder. Then this is going to be the slant asymptote or oblique, depending on whether this is a linear equation or not. And this will be the remainder, which whatever that is always going to be divided by qx. So as you can see, this takes a lot more work than this case or this case. This is by far the easiest one because the answer is 0. If the numerator is bigger, then you have to do much more work. All right, so let's look to the same example in which we just found the slant asymptote, but let's use the information that we learned in the previous sections to create a graph. So remember from before, if we want the y-intercept, remember y-intercept means x is equals to 0. So you plug in 0 here, this will be 0, 0, 0. So the answer is going to be 5/3. So that's the y-intercept. Now, if you want the x-intercept, remember x-intercept is where the top is 0. That means x squared minus 4x minus 5 is equals to 0. You can factor this as x minus 5. And then x plus 1. So the answer will be 5 for this one. And negative 1 for this one. Remember, this is the 0.50 and negative 1, 0. So this is one x-intercept, and this is the other one. Now here you have a vertical asymptote, and that's when x is equals to 3. Why? Because if x is 3, you're dividing by 0. So at this point you have a vertical asymptote. Now we did this before, and you actually did this, I believe, in the last offline homework. So this part is asking you the behavior near the asymptote. So the asymptote is here, 3. And remember, you can come from the left. I mean, sorry, from the right or from the left. So this will be from the right, this will be from the left. So this is 3 plus, and this is 3 minus. And all you have to do is just pick any values. Let's say you pick 4. If you plug in 4 in here, this will be negative. The next one will be positive, and the bottom is positive. So the whole thing will be negative. So that means that when you are approaching 3 from the left side, this is going to minus infinity. So this is going down. Then let's say you pick 2. The first one will be negative. By first one I mean this one. The next one will be positive, and then the bottom will be negative. So the whole thing will be positive. So if you are approaching 3 from the left, this is gonna go to infinity. Right, so therefore y goes to minus infinity as you approach 3 from the right side, and positive infinity if you approach from the left side. All right, so let's use this just to make a nicer graph in here, but just technically just copying this down. So this is the vertical asymptote. The only thing we haven't added here is the horizontal asymptote. Remember the horizontal asymptote or the slant asymptote was y equals to x minus 1. Okay, so that's what we did in the previous one. So you only worry about this part. Now, if you want to graph this, remember the y-intercept for this one is -1, so somewhere here, and the slope is 1. So if x is equals to, let's say 1, this will give you 0. So the graph would look something like this. So this will be the horizontal asymptote, which is called slant asymptote. And we already know that near the vertical asymptote, this is what's going on. This is going to minus infinity. Okay, so already saw that in this part right here. So what the horizontal asymptote or slant asymptote is going to do is this. The graph has to continue like this, and as you can see, it's going to infinity. And then the other side is going to look like this. And that's it. So as you can see, if the numerator is bigger, you have to do more work than when it's the same degree or the top is less than the bottom. All right, well, you didn't get that one. This is the chance to redeem your sins. So let's do one more. So here you have, instead of R, now it's called D, but it's the same thing. So this is the numerator, this is the denominator. So the first thing we do is you have to do long division. So you have 6x squared minus 26x plus 12. And here you have x minus 4. So the only number here that will give you this is going to be 6x. So this will give you 6x squared minus 24x. Then remember, change the sign. The first one always has to be 0, and in this case this is minus 2x, and just bring the other one down. Okay, so now you need minus 2, so this will give you minus 2x, then minus 8, and again change it should be plus 8, sorry, then change the sign, so this will be plus, this will be minus. Remember, the first one always has to be 0, and now this will be 4. So that will be the remainder. So that means the 6x squared minus 26x plus 12 divided by x minus 4 is equals to 6x minus 2. So that's the slant asymptote plus the remainder, which is this. Alright, so this is the slant asymptote. And this is the remainder, which in this case is called Rx. Alright, you didn't get the last two. Here's your last chance to redeem your sins. Remember that the key here is the long division, so just do the division carefully. So let's try the next example. Here we have x cubed plus 3x squared. There is no x, so you should put 0x, and there is no constant, so you just put 0. And you are dividing this by x squared minus 4. Okay, so you need an x to get x cubed, so this will be x cubed, and then plus 0 x squared, and then minus 4x. Okay, then remember change the sign, so this will be minus, this is plus. Make sure that you always get 0 here, otherwise this is wrong. And then it will be plus 3x squared plus 4x. Right, again, what's the only thing you need in here to give you 3x squared? Well, you need to have a plus 3. So then this will be 3x squared plus 0x minus 12. Change the sign, and this will give you 0. This will be plus 4x plus 12. Right, so therefore the horizontal slash slant asymptote, just like the previous two examples, is going to be y equals to x plus 3 in this case. Why? Because remember, this Rx, you can just rewrite it as x plus 3, and then plus 4x plus 12 divided by x squared minus 4. All right, so now this is a continuation of the previous example. We already found the horizontal asymptote, so we need to find the y-intercept, x-intercept, and the vertical asymptotes. So remember, for the y-intercept, that means that x is 0. So if x is 0, the whole thing will be 0 over -4, so this will be 0. So that's the y-intercept. For the x-intercepts, you need the top x cubed plus 3x squared to be 0. Here you can factor x squared, so this is x plus 3. So therefore the x-intercepts are x equals to 0 with multiplicity 2, and x equals to minus 3. And the vertical asymptotes is where the denominator is equals to 0, or whatever is not part of the domain. Okay, so remember, this will be x equals to 2. That's one vertical asymptote, and x equals to -2 is the other one. So you're going to have one here, and then you have x-intercept at 0 with multiplicity 2, and then -3. All right, so this time, before I plug in the values to see the end behavior, let me write Rx in factor form, so this may be easier to see how we got the signs that we got. Okay, so let's say you want to know what's happening here, so let's pick, say, the number 3, or well, let me put the 3 here. So if you plug in 3 in here, remember the first one is going to be positive. It's always positive. The second one is positive. This one will be positive, and this one positive. So everything is positive. So, which means if you are approaching 2 from the right side, this is going to infinity. All right, so now let's say we pick 1. If we plug in 1 in here, this will give you a positive value, then positive, this will give you a negative, positive, so the whole thing will be negative, which means at this point this is going to minus infinity. All right, here let's say we pick -1. The first one again is always positive because it's a square. This will be also positive. This one will be negative, and this will be positive. So the whole thing will be again negative. So therefore the graph is going to go down like this. Now remember that it has to go through 0, and it has multiplicity 2, which remember it has to do this. So this is technically how the graph is looking now. And here, let's say you pick 2.5, because it has to be between these two. and it has to pass through -3. So let's say you pick minus 2.5. Again, this one will be positive, this is positive. The bottom, this will be negative, and this will be negative. So the whole thing will be positive. So therefore the graph in this side is doing this. So that's pretty much how the graph is going to look. The only thing we haven't put in is the horizontal asymptote. Remember, the horizontal asymptote was y equals to x plus 3, which if this is the y-axis, when x is 0, this is 3 somewhere here. So the the horizontal asymptote is going to look something like that. Right, so remember this is just a sketch, so let's do a more formal graph in here. So we still have the vertical asymptotes here of 2 and -2. We have the y-intercept, x-intercept at 0, and the y-intercept was also 0, and the x-intercepts were -3 and 0. And we already did this part, so this should be easy. Now the horizontal asymptote, let's say that 3 is here, so the line is going to look like this. And once you plug in the values, we already know that this one has to go to infinity. The graph actually does this, and in this case it has to pass through this point, so it will do this. So that's how the graph will look. If you have a graphing calculator, you should definitely use it to check that this is how the graph looks. You can also use a Google calculator from the browser if you don't have a calculator, to check that this is what's going on. Right, so now we already answered this graphically, but now in writing, so the behavior near the vertical asymptote, so let's say we look at 2, and then what happens from the right, from the left, and then at -2, -2 from the right, and -2 from the left. So as x approaches 2 from the right side, from this is going to infinity, and 2 from the left side, this is -infinity, which is this and this. And then as you're approaching -2 from the right, this is going to -infinity, and this is going to infinity, which is this and this. All right, so let's go to the next example. All right, so in this example, this is already telling you that this doesn't have a slant asymptote. Instead, it has something that is square, and you'll see what I mean right now. So let's do first the long division, and then it will make more sense why it's not called a slant asymptote. So we're dividing this by x minus 2. So this will give you x squared, so it will give you x cubed minus 2x squared. Then change the signs. This is 0 and this is 0, and this is actually pretty good because technically you're done. So therefore this is equals to x squared plus 3 over x minus 2. Now, since this is not a linear equation, that's why this is not called a slant asymptote. But in either case, this will tell you the end behavior, or the asymptotic, that's the fancy name, behavior. Okay? So now, let's do the same thing. What is the y-intercept? If x is equals to 0, this cancel, this cancel, this cancel. The only thing left are these two. So it will be 0, negative 1.5. Now the vertical asymptote is going to be x equals to 2 from here. And then the horizontal asymptote is going to be y equals to x squared. Now to find the x-intercept for this one is actually more tricky since this is not a quadratic equation. So that makes the problem more complicated. But here, and this is kind of cheating a little bit, you can see that if x is equals to 1, this will be 1 plus 3. Sorry, if x is equals to negative 1, this will give you negative 1, and negative 2, that's negative 3, plus 3 will be 0. So therefore, if x is equals to negative 1, we have negative 1 cubed minus 2 times negative 1 squared plus 3, and you can check that this equals to 0. So therefore, the x-intercept is going to be the point minus 1, 0. All right, so therefore, this is what we have. You have a vertical asymptote of x equals to 2. You have a x-intercept at negative 1, 0. And then a y-intercept of 1.5, so something like this. Okay. So next we need to determine the end behavior when actually the y-intercept is negative 1.5, so it should be somewhere here. So we need to determine the end behavior when you're approaching 2 from the right and from the left. And we can use the exact same technique we used before. So let's say we pick the number 3. If you plug in 3 on the top, this will be 27 minus 18 plus 3. So the whole thing will be positive on the top. On the bottom, it will be positive. So the whole thing is positive, which means close to this one, this is going to infinity. Then let's pick, let's say 1.5. So the bottom will be negative, but the top will be positive. You should check that. Therefore, the top will be positive, the whole thing, and you should check the bottom is going to be negative, so the whole thing will be negative, which means when you're getting close to 2 from the left side, this is going to minus infinity. All right, so let's do a better graph, whatever that means. So here is the asymptote again at x equals to 2. The y-intercept was a negative 1.5, which is somewhere here. The x-intercept was a negative 1. And we already know that the end behavior here is going to go to infinity from this side and negative infinity here. So now the graph, and it's a little weird, it's going to look something like this because it has to pass through these 2 points. Then since the horizontal asymptote is equals to x squared, the end behavior is going to look actually like square this. So that's how it's going to look. And again, if you have a graphing calculator, you should definitely check this out so you can convince yourselves that that's how the graph is going to look. All right, so this question is a lot easier than all the examples we did before. This is actually exactly like we did in week 12. So notice here that the degrees are exactly the same. So therefore, from what we learned before, the horizontal asymptote is just going to be y equals to 2 over 1, which is 2. That's it. That's what you even have on the exam. So what is the end behavior for this? Well, this means that y goes to 2 as x goes to minus infinity, and y goes to 2 as x goes to infinity. So this is not new. So we have done this before. Here I'm gonna make a side note or mini lecture in something called synthetic division, which it can be very, very helpful to find solutions of polynomials. So synthetic division is an alternative to long division, which long division can be pretty long. However, synthetic division doesn't work all the time, well, long division does. But just for example, remember you have a case where you had to divide the 6x squared minus 26x plus 12 divided by x minus 4. So we did that one in the previous examples. So this is how synthetic division works. You just copy the coefficients and make sure that they go in ascending order of the degree. So this is 6, 26, and 12. If there is any degree missing or any x missing, you need to put a 0. And then you always change the sign. So if this is minus, then you're going to use plus. If this was plus, this will be minus. Okay. And then synthetic division is pretty fast. So just this one goes down. That's always the first step. And then just multiply this times that. So 6 times 4 is 24. And then add. So this is minus 2. And then minus 2 times 4 is minus a. And the remainder is 4. So the last one is always the remainder. And if the remainder is 0, that means that this is a 0 or a solution to the problem. Okay. So what this means automatically is that if you divide this over that, the answer, that 6x squared minus 26x plus 12 divided by x minus 4 is going to be equals to 6x minus 2, which is this part, and then plus 4 over x minus 4. So synthetic division is faster, but it only works if this is linear equation. If this is a quadratic equation, then it won't work. And by that I mean synthetic division will not work for a problem like this, because this is not a linear equation. But it will work for the previous very last problem we did. So remember, in the last problem we have our x cubed minus 2x squared plus 3 divided by x minus 2. So here synthetic division will work and it will be pretty fast. So it will be 1 minus 2 and then 0 because there is no x, then a 3. This will be positive 2 since this is negative. Then just bring the first one down. 1 times 2 is 2, this is 0. 0, and then the remainder is 3, which is exactly what we got before. So this will be equals to x squared and then plus 3 over x minus 2. Now, if you have the same degree, you can still do the long division, okay? And in calculus, you may have to do this a couple times for something called partial fractions. So if you divide, well, then this will give you a 2, and this will be 2x squared plus 2x. Then change the sign. This is minus, this is plus, so this will give you 0. This will give you 4x minus 4, and this will be the remainder. So therefore 2x squared plus 2x minus 4 divided by x squared plus x is going to give you 2, which we know that's the horizontal asymptote, plus 4x minus 4 divided by 2x squared plus 2x minus 4. Sorry, divided by x squared plus x. That's it. But what we call the slant asymptote now is just the horizontal asymptote. But notice that if the degree is the same, this takes a lot more work to do just to get 2, when you could just divide the coefficients. 2 over 1 gives you 2. But if the degree of this one is bigger, you have to go through this, which is the whole point of this section. And that's it.